Law of Cosine, finding a missing side in an SSA scenario where we see two possible outcomes. Now, why are there two possible outcomes in an SSA scenario? Because SSA scenario, SSA does not guarantee congruence of two triangles. What it means is that two triangles can have congruent two pairs of congruent sides and one pair of congruent angles, but if the angles are not in between or not included in those two pairs of congruent sides, the two triangles are not necessarily congruent. Okay, now how do you illustrate that? For example, if I have a triangle, say I have a triangle, okay, this is 15, let's say this is 8, all right, and this is 20 degrees. Okay, so I have one triangle, two sides are 15 and 8, and the angle not in between those two sides is 20. Now I can have another triangle with this set of sides and angle and yet not be congruent to the first triangle. Okay. That means I can have another triangle. Let's say this is 15. Okay, I have an angle here that's also 20 degrees, but I can have a side here, my 8, okay, can go that way instead of the other way. Okay, so my triangle looks like this. So I have, okay, remember the other triangle, in the other triangle 8 is right here, okay, but here 8 is over there. So I have two triangles. They have the same set of sides and angle, okay, that are given, however they are not congruent. So that's what we call the ambiguous case, and that's what we're dealing with here, and you will see that. Okay, this is not new. You have heard about the ambiguous case when you studied, I hope you studied, the law of sines. Okay, so if you paid attention while doing the law of sines, this should not be new to you. You're not hearing this for the first time. Okay, now but this time we're going to be using the law of cosines. So still SSA scenario, let me clean this up. Okay, let me make some space. Okay, given triangle PQR with P is equal to 12, Q is equal to 16, and measure of angle P is equal to 30 degrees. What are the possible values for the length of side R? Write your answer to the nearest tenth, 0.1. Okay, so now we don't have a figure, so let us draw our figure. Okay, I have angle P first. Okay, let me draw my angle. It's gonna be angle P. It's gonna be 30 degrees. Okay, that's my angle P, 30 degrees. Okay, now let's say this is R and this is Q. Okay, Q right here. So now P, okay, angle P is 30 degrees, side P is 12, this is 12, and okay, side Q is 16. Mr. Abalos, how do you know that 12 is there and 16 is there? Okay, well, if you're paying attention, okay, you know that side P is opposite angle P and side Q is opposite angle Q. That's how simple it is. Alright, so we're being asked to find the length of side R. It's gonna be R is right here. This side right here is R. Okay, now because we have SSA scenario, we know that there are two possible places that RQ can go. Okay, so this 12 right here can also be found, not just there, can also go this way. Okay, let me erase that part right here too. Okay, so we can also have the 12 there. Okay, let me write down this. It can be 12. So 12 can be here, 12 can also be there. So therefore, our R can be this R right here. This is small, this short version right here, or we can have the long version of R. This is R right here. No. Okay, it's gonna be that R. Okay, that's what we're gonna be finding. All right, so since we have, okay, we can use the law of sines here. Okay, 30 is the angle. All we need to use are the sides that include the 30-degree angle. This is gonna be, again, I told you to not memorize the 3 versions of the law of cosines. Like I did not ask you to memorize the 3 versions of the law of sines. You only have to memorize A, B, C. Okay. The law of sines states that in any triangle, okay, A with sides A, B, and C, okay, A squared plus, okay, A squared plus B squared minus 2 times A times B times cosine C is equal to C squared. Yay. Okay, is equal to C squared. So now, our A and B are, well, R and 16, because they are the sides that sandwich, okay, these two sides right here are the sides that sandwich the given angle C. Okay, the sides of angle C. So it's gonna be what? R squared, R squared, which is this side right here, or that side, okay, plus 16 squared, which is that side right there, this one, okay, minus 2 times R times 16 times cosine, well, angle C is actually angle P, it's going to be 30 degrees, is equal to, well, our C is the side opposite opposite angle C, which is 12 squared. Okay, so now let's do some simplifying. Okay, it's gonna be, well, R squared plus, okay, 16 squared is 256. Okay, 2 times 16 is 32 minus 32R times, well, cosine 30 degrees is 0.866. Okay, is equal to, well, cosine 30 degrees 0.866. You can get that by using your calculator. Is equal to 12 squared is 144. Okay, so now let's do further simplifying. We can multiply 32 and 0.866. Okay, so you have R squared plus 256 minus 27.712, that's 32 times 0.866, okay, is equal to 144. Okay, now we can collect all the terms to the left side of the equation so that we say that the equation equals 0 by subtracting. Let's just kick this over to the other side. It becomes R squared plus 256 minus, okay, we have an R here, okay, minus 27.712R minus 144 is equal to 0. Okay, and then let's rearrange this equation so that R is next to each other. So it's gonna be R squared, okay, minus 27.712 R plus 256 minus 144. I'm just doing the rearranging here. Okay, so now we can combine 256 and 144. So it's gonna be R squared minus 27.712 r. 256 minus 144 is equal to 112. Okay, 112 is equal to 0. Okay, so if you notice that we have a quadratic equation here. Okay, this is an equation in the form. Okay, let me write here. We have an equation in the form x squared plus ax squared. Ax squared plus bx plus c is equal to 0. Okay, let me write it down. We'll separate a little bit. Okay, so this is gonna be ax squared plus bx plus c is equal to 0. Now in this case, instead of x we have r. So a in our equation, a is equal to 1. B is equal to this fellow right here, 27.712, and C is equal to 112. Okay, now if we have a quadratic equation, we can use the quadratic formula. Okay, you should remember what is the quadratic formula. Quadratic formula. The quadratic formula says that, okay, if you have a quadratic equation, ax squared plus bx plus c, x is equal to, my pen is acting up, x is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay, that's what we're gonna use. So our a is 1. We have a 1 there. Our b is 27.712. That's our b. That's negative 27.712. 27 is going to be negative right here. Negative. And our c is 112. So instead of x, we have r. It's going to be r is equal to, okay, negative of negative 27.712, okay, plus or minus the square root of negative 27.712 is a lot of work, squared, minus 4 times our a is 1, our c is 112, okay, all over 2 times 1. Okay, so what I did is I already evaluated the radical for you. It's going to be r is equal to, well, negative of negative 27.712 is 27.712 plus or minus, okay, the square root of all of this, the square root of all of that is 17.887. So do that in your calculator. You're gonna get 17.887. So I'll write it down. Okay, 17.887 all over 2 times 1 is 2. So all we have to do now is separate, okay, separate the plus and minus. So I'm gonna work with the plus first, okay, right here, okay. So if I do the plus part, it's gonna be 27, so it's gonna be r is equal to 27.712 plus 17.887 divided by 2. I'm gonna get 22.8. 22.8, okay, centimeters. So that's this long, okay, this long version of r is equal to 22.8. So this is going to be 22.8. Okay. Now, next up, okay, if I'm going to take the minus version, okay, it's going to be or, I'll say or, R is equal to 27.712 minus 17.887 divided by 2. I'm gonna get, okay, 4.9. 4.9. That's gonna be to the nearest centimeters. Okay, it's nearest 10. Okay, so it's gonna be, that's gonna be that 4.9 is this version right here. This is gonna be 4.9. So I have my two solutions. One is 4.9 and the other one is 22.8. The two possible solution is 4.9 and 22.8. So I know this is a lot of work. A good thing about videos is that you can pause it, you can go back if you miss something in the step. Then you can email Mr. Abalos if there's a step that you don't really understand. Okay, but what I want to make sure is that you watch this video for your own sake, for your own learning, and not just skip this instruction that I'm doing my best to prepare for you. Okay, not just for you to skip them. All right, so we have a version of the application of the law of cosines. This time using the SSA. Whenever we have SSA scenario, it always results in ambiguous situation. We can have it can result to more than one possible outcome. Okay, now in any case, if one of the values is negative, you can strike that out. The negative value for side is not possible, it's not acceptable, meaning the situation, although it is SSA, actually only result in one triangle, and that's the case when this side right here is longer than this side right here. Okay, which I actually illustrated when you took the law of sines, if you paid attention. All right, so yeah.